Yesterday we were running some Docker containers. So let's just get a list of the Docker containers. The command is docker ps-a. You get a list of all the containers that are there on your system. And if you do a Docker PS, we actually don't have any containers out there. So it's only Docker ps-a where all the containers are there. That means all of these containers are currently in the exited state, or you could also call it as the stop state, right? Now, these Docker containers, right, all of these containers that you see on the extreme left, the container IDs, right, these are actually running on certain images. That these images are like Nginx image, Ubuntu, Hello World, and stuff like that. Now, to understand or to know what images are there on your laptop, you could run the command called as docker images, which says Ubuntu, Nginx, and Hello World. These are the three images that are actually there in my laptop as of now. Now, the thing that you have to see is the size of the Ubuntu image. The Ubuntu image, the size is only 117 MB, right? It's not big. It's very small when compared to the operating system or the ISO image, which has the entire OS kernel and everything along with it. 117 MB of the entire container is very less. Now you have other distributions like Alpine in Docker, which is just like 30 or 40 MB in size. That's right. So there are smaller images as well. So this is something, you know, if you want to look at the images in like a pretty form, right? You could use this command. Not that I use it every day, but it's out there, so you could still use that command. If you run this, it's just going to give you it in a pretty format where it says repository and size. What is it missing? I don't know. What is it missing? The created date, right? So basically, what we are not having is the created date, which is over here. Now, how do you remove images? Let's say you want to save some space on your machines, right? Now, if you see the hello world image is consuming 20.4 kilobytes, right? It could be any other image. Let's say it is an image which is consuming, let's say 500 MB of space, which is very much possible, right? And if you, as you keep on adding more and more stuff to your containers, that is more and more software and packages and libraries, the thing will keep on increasing, right? So that's the hello world example. Now, let's say you want to remove this image or you want to delete this image. How do you do it? So you could say docker rmi, that is remove image rmi, and you will just say the image id. And what is this going to do? It is actually going to delete the image. But before deleting, it is going to give you a very small subtle error saying that there is Docker container, this which was run using it, and it is still available. It is, sorry, this is the image. This is the Docker container which is available on your host, Docker host, and it's still there. So what would happen is if you try to delete the image and then again if you try to run the Docker container, that would not start because the image itself is not there, right? So what are we going to do? We are going to do a docker ps-a. We're trying to see if this actually matches with the hello world example. Yes. So the first thing that I'm going to do is docker rm, and this is actually going to delete the container itself. So it is going to delete the container on your system, right? So docker rm is going to delete the container, rmi is going to delete the image, right? Now you see that the image was deleted successfully. Earlier it was throwing us a response. Error response was from the daemon conflict. It was unable to delete the thing. Now if you try to do a docker images, you will see that there are only two images left on your device, that is Nginx and Ubuntu.
Yeah.
Right, so this is Dr. RMI. Uh, okay. Why do I have some slides which are duplicate? I will just keep this. Cool. So we went with this example of deleting the images. So that's something that we ran. Now let's try to understand the life of a Docker container. Now we did go through it yesterday briefly, but I would again try to emphasize on what the containers are actually doing. So if you see, Docker containers only live for as long as the process inside the container is alive. This is very, very, very important critical thing, because whatever process you are running inside the container, right? Now, a Docker container is not like a operating system, like a VM wherein you run multiple processes, right? A Docker container is solely and solely used for running one particular process service that it is going to serve. Right, so there's only one process that runs inside a container, and that process is given as PID number one on the Docker container. So what actually happens is, if I could open a new slide, which should be a blank one. So actually, I have the slides for the process mapping in somewhere later down the course, but let's say there is a Docker container, right? The Docker container is running a process with PID number one. So this is inside the container, but this Docker is actually running on the host, right? Now what happens is, this PID is actually, because the Docker container is not having a kernel of its own. So what actually happens is, another PID, let's say 3214, a random number, is generated or is created on the host operating system, and this is where all the process is running. So now this PID is actually going to reach out to the OS kernel. OS kernel is going to reach out to the CPU, RAM, network, storage, and then it is going to do all of its processing. And once everything is done, this PID is going to send it back to, so kernel is going to send it back to the PID 3214, and this is going to send the response back to Docker container. So this is how the process mapping is done. Now, if PID number one, right, the first process ID itself is not running, and the container will also die, or the container will also be stopped, right? So if the service inside the container is dropped or crashes, the container also stops. Same with the operating system. In an operating system, if PID number one of the operating system, if that goes down, then the OS also shuts down, right? The OS will also shut down, because the first process ID is responsible for running or booting the entire kernel, right? So something similar happens in containers as well, and this is how it is done. We can take this example that we used yesterday. So let's go with this example, Docker. PS, you don't see any containers running. So let's say Docker run. I would be running Ubuntu, and so I let's say I run sleep for like 20 seconds, right? This is all I did. So what is happening? Docker is running the sleep command. So here, if you see Docker PS in the other tab, right, you see that sleep 20 is being run inside the container, and the container is going to be alive for roughly 20 seconds, up 19 seconds, and now that the container is stopped, if I do a ps-a, you will see that the container exited 4 seconds ago, 26 seconds ago it was created. Uh, Almost all 20 seconds is what it actually ran,
Mm-hmm.
right? So this is the life cycle of the container. Very, very, very important. If the container stops, sorry, if the service inside the container stops, the container will also stop. That is the Docker PS, the Docker container that is running, right? That will also be gone. Very, 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 very important thing. Attached mode and detached mode. This is something also we discussed yesterday. So when we execute a Docker run command, right? Let's say I say Docker run nginx, right? Let's say I'm running nginx. Sorry, the spelling is wrong. Nginx. Let's say I run nginx. So what has happened is this Docker command, right? This Docker run has consumed or occupied my terminal, right? It has occupied my terminal. I can't do anything in this terminal now unless I cancel or control C, unless I interrupt the thing that is running, right? Now this is called as an attached mode. It runs the container in an attached mode. In this mode, the container occupies this shell and would show the standard out log of the container. So whatever the standard output is, we will be looking at that. How to run it in detached mode? All you have to do is say hyphen D. If you say hyphen D, I'll just cancel this out. If you just say hyphen D, that means it is going to run in a detached mode, right? Now, if you do Docker PS, you will see that the Docker container is running, and uh, it is not going to stop even if you do a control C or anything, because we are already out of the shell. How do we stop this container? Something that we saw yesterday. We said Docker stop stop the container ID, and this should stop the container. Docker PS, nothing is running. Docker PS -a. You see a lot of containers out there. How do we get rid of all the containers? So you can say Docker RM. You know, you need to provide a Docker ID of individual containers one after the other. Else, what you could do is maybe put something like this: Docker PS-a-q. This now what is this going to do? Let's first show you this. So what is this going to do? It is only going to give you the container IDs. Now what I'm trying to do is all of these container IDs, I am trying to put it in a dollar, like a variable kind of thing. And what is it going to do? So Docker RM this Docker PS-a-q is going to give me the list of containers. Now, how do we attach and detach a container? Again, it's very, very easy. You definitely would not like to attach a container, but if you want, you can still do it. Uh, you could see any running container that is out there, and then you could say the command is docker attach and the container name. So let's say docker ps, nothing is running, docker run hyphen d nginx. So the nginx container is running docker ps. Now what you can do is docker attach and then the container name, and this will give you the container would be attached to your system, right? So it is now attached. The only thing is you're not seeing any logs because there are no new logs being printed. If you do a control C, you see that there are some logs that get printed and then the container exits, right? So this is basically what is happening with the attach and detach mode of the container. After this, we have a very, 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 very important command in Docker, that is execute. Docker exec. So what is Docker exec? Let's say there is a Docker container. So let's say there is a Docker run Ubuntu, and I want to sleep this for, let's say, 10,000 seconds. Okay. Now, what I also want to do is hmm, okay, the spelling of Ubuntu is wrong. What I also want to do is run it in the what do we call, the detached mode. Let's say I put 1,000 seconds, more than enough for our demo. I have this Docker container that is running. Now let's say I want to run some remote commands on this Docker container, or let's say I want to go inside the Docker container and see what is happening, right? So what you can do is you can run the command called as exec, Docker exec, If you do an hyphen it, it is going to give you an interactive shell, right? It is going to give you an interactive shell, and all you have to say is bash. So, right? So this is the command that you want to run, and it has given you bash ps-ef. You see that there are only three services that are running, three processes. PID number one is the sleep process that I was talking about. So whatever the main command was used to run the Docker image, right? So that becomes as the process ID number one. Is it necessary that we always provide the process ID? Not needed, right? So the, let's say the Nginx container that we ran, we didn't provide any command after that, right? We didn't say sleep or anything. We just said Docker run Nginx, and that's it. It ran Nginx for us, because Nginx is something which works as a web server, so you don't need any overriding or any additional features to be run with that. But let's say in an Nginx server you want to run something specific, yes, you can then provide what you want. Right? So Docker exec, this is giving you a sleep of 1000. If I exit this, and if I now say Docker ps, right, this is not going to delete the container. Make sure this is not going to delete the container. But what you could do is, instead of going inside and running ps-ef, you could directly run ps-ef from the outside also. Here, if you see PID number 7, which was bash, which is when we it actually stopped the bash process actually exited or stopped when we hit exit. So when we came out of this shell, this process ID was gone. PSFNEF is the 16th process that actually ran on this server. Now it is PSFN. Now this PSFNEF is the 16th process that ran. If I do it again, this would be something else, right? So it keeps on incrementing, and this is how you get it. Let's say you want to check the operating system version, right? So cat etc os release, release, and it is going to give you release. Okay, not giving it to me. Okay, now that I'm doing a cat, right, you don't actually need an interactive mode also. So let's get rid of the exec interactive mode. Let's just do a cat and see if it even gives. Okay, Docker PS is the container there. Yes, the container is there. So that's actually going to Docker exec again IT, the container name, and then bash, and then go into cd etc ls-l. Do we have os-release? Yes, os-release is there. Yeah, it is there. So then again, cat. Okay, you're getting this. You're getting this error because what is happening is what is happening is because I'm running this on Windows, right? So this is git bash on Windows, right? So what is happening is docker exec, this command, right, is confusing etc os release to this file actually, right? So what it is thinking is this is the place where it is running the command, whereas the actual place where the command should be run is inside the Docker container itself, right? Now there is a fix for that. I'll actually look for that and discuss that in the next video. So there is a fix that we have to. There is a command that we have to run prior to running these commands, and that would behave like Linux. But if you run this same thing in a Linux container, this is going to run exactly the same way. So this is actually going to read the /etc/os release of the container and going to give you the output, right? So this is how it actually works. But Docker exec is very, very important if you want to actually understand what is happening inside the thing. Here, if you see, okay, yeah, I have some other terminal as well. So let me open mobile down.